Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today we are going to write a C++ program to implement queue data structure using singly linked list data structure. Yes, so this is the practical side of queue using linked list, where we use a singly linked list in such a way that it works like a queue. And this video is the practical side, that is we are going to implement it using C++ programming. If you don't know any of these two data structures, that is queue data structure or linked list data structure, then please watch this course. Inside this course I have separate tutorials on all these fundamental data structures. First go watch them. If you already know them, you're good to go. And if you don't know how the operations and the working would work like behind the scenes in detail, you can check out the part 1 of queue using linked list, where we've discussed visually each queue operation using singly linked list, the difference between queue using singly linked list and queue using array, and all the operations that happen behind the scenes in memory taking visual representation. So that would make things very easy to understand, because in this video we are simply going to take those pseudocodes and just write the code and do the practical implementation. Okay, so with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. So as you can see on the screen, I've already opened up my Dev C++ IDE and I've already typed quite a lot of code. Now this is some basic boilerplate, so I don't want to waste time typing this code. I'll quickly explain to you what it is. So since we are going to use singly linked list and make it work like a queue, the element and the unit of data stored in a singly linked list is called a node, right? So a node comprises of key, data, and a pointer that points to the next node. Since we are going to use singly linked list, we do not have two pointers, we only have one pointer, which is called as pointer next. So this class node is basically creating that template class which will create objects of node, and then we will add those nodes in the singly linked list, but in such a way that they work like a queue, right? So that's the end goal. So this class is nothing but a node class which has three data members, key, data, and a next pointer of the same type node which points to the next node. Okay, then we have two basic constructors. One is default constructor. So if you create a node without any parameters, the key and data is set to 0 and the next pointer is set to null. But we are going to use this parameterized constructor wherein we will pass the key and data from the main function. And of course, when you first time create nodes, the next pointer initially will be null. Then we will make the linking later on via the different queue operations and make this singly linked list work like a queue. Okay. So this is the basic node class. If you want, you can pause the screen and type it out yourself. If you're an absolute beginner, I highly recommend that you type the code first time at least. But if you're still bored, you can check out our official website. I have shared this code and other resources over there onto our website. You can check the link in the video description. But again, please type it out at least once. So let's move ahead. After this, we have the main queue class. Okay. So this queue class is where we will have two data members, which is the front and rear. So remember, in a queue we have two pointers or two data members which point to the rear and the front of the queue. The queue operates in first out mode, so I hope you already know that, wherein the data is inserted or enqueued from the rear and it is dequeued from the front. Hence we require two pointers which are again of type node, because we're going to insert, that is we're going to enqueue and dequeue nodes only, right? So that's why we have two pointers which keep a track of the front and the rear. Initially, obviously, when you create the queue, the default constructor will be called, where the front and rear will be marked as null, because initially we will not have any node in the queue. And of course, we will have some standard queue operations, which is enqueue, dequeue, count, check if node exists, display, and so on and so forth, which are standard to the queue data structure, and we will implement those over here in a minute. After that, our entire queue class will be ready. That thing we will type it out and try to understand step by step by taking the pseudocode as well and the diagrammatic representation. Moving on, in the main function is where all the action happens, right? In a C++ program, the main function is the starting point. So I'm assuming you guys already know the basics of C++ programming. I have a complete C++ programming course as well. If you have any queries about some concepts like pointers, classes, and objects, you can check that out. But in the main function, we will create this queue object. We will say queue. So this is that class. So we create an object in the main function. Then we declare three variables as option, key and data. I'll explain to you what this is. But what we want in our program is we want to create a menu driven program. So a menu driven program will give us a menu, and that menu in the command prompt will be as follows. These are the instructions that will be printed on the menu. It will ask what operation do you want to perform, and it will say select option number and enter 0 to exit. So depending upon the operation number, the following queue operation will be performed. So if the user enters 1, we will perform enqueue. If the user enters 2, we will perform dequeue. 3 is for isEmpty. 4 is for count. 5 is for display, and 6 is to clear the command prompt. It is an extra thing that we've added over here. So this will give us a menu driven program which we can utilize and perform all the different operations without our program closing in on us. Okay. So that option number we will take from the user, hence this variable int option. Now moving on, this entire menu driven program will be placed inside a while loop, inside a do while loop basically. So the basic difference between a do while loop and while loop is in do while the condition is checked later on. So the first iteration always happens without any condition checking. So it's an exit controlled loop. I'm assuming you guys know that as well. And this do while loop will keep on executing till the option number is entered 0. So you can see we've mentioned enter 0 to exit. So in the do while condition, if you scroll down, the option condition in the while is while option not equal to 0. This do while loop will keep on running. So once the option number comes 0, this do while loop will exit. Till then it will keep on printing this menu screen and taking input from user over and over again, and we will keep on performing different queue operations. Okay. Alright, so let's move forward. Now here is where we create a pointer to a node, and we will use this new node further inside our program. So now there are two ways in which you can create an object. You can create it using the static memory allocation methodology, or you can create the object using dynamic memory allocation methodology. So what are these two things? I'll just try to explain in brief because that is not the main topic. But over here on the top you can see I've created an object node n1 is equal to new node. So when you use this methodology, what happens is in the memory we have two different kinds of memory. We have the stack and we have the heap. So the stack is associated with static memory allocation and the heap is associated with dynamic memory allocation. We can get into the details in some other video tutorial, but right now just understand that there are two different types of memory. And the first type, the first methodology of node n1 equals to new node, it creates a node object in the stack memory. Okay, so inside the memory we will create or allocate some memory space to this node n1 and it will be named as n1. Okay, so that node memory area will be referenced or named as n1. So how is this different from this methodology and why are we using this different or second methodology? I'll explain that. So this second methodology, when you say node star new node, it is how you define a pointer, right? When you use star, it is basically a pointer. So this new node is not exactly an object, it is a pointer of type node. And when you say equal to new node, what happens is in the heap memory a node object is created, and this new node is a pointer which is in the stack memory. It is pointing to that new node. Okay, so I hope you are getting the difference between the two. When you create a node using this methodology, node n1 equals to new node, it is created into the stack memory in the static memory allocation side. n1 is actually the name given to that memory space and it is actually that node itself. When you use this methodology, what happens? A pointer is created in the stack memory with the name of new node and the type of node, which means it will point to only node objects. But the actual memory allocation of the node happens onto the heap memory, and this new node will point to that memory or it will store the address of that memory. So you can visually also see I've tried to depict the two different cases. And now if you're wondering why are we going this route, the simple answer or simple explanation is because when you create objects using this methodology, their scope is global, which means that that memory allocated into the heap memory has to be destroyed by you explicitly, otherwise it will remain throughout the program irrespective of what scope or where exactly it is written. Okay, so when this loop will run over and over again, if we use this methodology node n1 equals to new node, this n1 will get destroyed every time this loop is again reiterated. But when you use this methodology, that node created inside the heap memory will be there throughout the entire program. Okay. So I know I'm trying to explain to you in a very brief way, and this is completely separate topic which we can discuss in other tutorial. But if you're still confused, you can try to go this way also. Just uncomment this and name this as new node and see if your program works. It will throw you an error. And if you want more detailed explanation on the difference between the two, let me know in the comments. I'll try to make a separate video. But anyways, moving on. Now that you've created a pointer to that new node, this new node is a pointer to that new node. Then we use the switch case to take in the options which are entered by the user. So as I mentioned, if you enter 1, remember what happens? Enqueue operation happens, right? So case 0 is for break. So when the user enters break, we will break out of the program will stop. So when you enter 0, we will break outside the switch case, and outside the switch case is this place, and here we will check while option not equal to 0, but the option is 0, so we will exit outside the while loop also, and the program will stop working. Case 1 is for enqueue operation. We will add the node inside the queue, and all this explanation I'll give you later on when you actually create the function. Case 2 is for dequeue. Case 3 is for isEmpty. Case 4 is for count function. Case 5 is for display function. And case 6 is an extra case to clear the command prompt. And this is a inbuilt function system, and you have to pass CLS to clear the screen. If you're using Turbo C++, I guess it would be CLR SCR. Remember that command. And then if you enter some wrong number, we will say default, enter proper option number. Okay. So we will discuss the individual queue operations like enqueue, dequeue in detail. But this is just the overview that I'm trying to give you in the main function what is happening. And now let's put our focus onto the queue class. Because inside this queue class is where we have to create these individual queue operations, individual queue functions and member functions. Okay. So let's start with isEmpty member function. Okay, so as the name suggests, the isEmpty member function checks if the queue is empty or not, which means that is there any node inside the queue or not. You can see the pseudocode on the right as well, and it's pretty simple. So let's start with bool isEmpty. So it will return true or false, hence the return type as bool. And the simple condition we have to check is if front equal to null and rear equal to null, that would mean that our queue is empty. So return true, else return false. Pretty basic, because our queue will be empty if front and rear are pointing to null. So initially when you create the queue also, you can see the front and rear will be pointing to null. That is, null is stored in the pointers. These are pointers. Okay, so remember we are playing with pointers. If you're confused with pointers concept, I have a separate tutorial that explains what is a pointer. Do check that out. But yeah, this is a pretty basic function which checks if both the front and rear are pointing to null. If yes, it would mean that the queue is empty. Alright, so let's move forward. So the next function or the next operation that we'll create is another utility operation, another utility function, which is check if node exists. Now as the name suggests, this function will take a node or take a pointer to the node, and it will see whether that node already exists into the queue or not. How it will check that? It will try to match the key of this new node with all the keys of the existing node. Now remember, our condition, our criteria of this queue data structure and the nodes is that every node will have a unique key. It can have same value, that is, two nodes can have the same value or data. So value and data is one and the same thing. Okay, so this in data is nothing but value. Also you can call it value, don't confuse between the two. So what I'm trying to say is two nodes into our list can have the same data, but it cannot have the same key. That's our condition, and that's how we check if a node already exists or not, by checking if the key value matches or not, right? So let's assume there is a queue and we have three nodes in it, n1, n2 and n3, having the key values of 1, 2 and 3 respectively, and we have to enter n4, which also has the key value of 3. So this situation has to be avoided, right? We cannot insert or we cannot enqueue n4 with key value of 3 because we already have n3 with the same key value. So that has to be checked over here. So that's why we have to create this function. And again, this will also have a return type of bool and we will say check if node exists. Now it will take a pointer to a particular node, and I'll tell you why we need a pointer to a node and not a direct node, because we are playing with pointers basically. So the first step inside check if node exists is we create a node temp. So again a pointer node star temp, and we say equal to front. Okay, so now again let's take our same scenario. We have 3 nodes inside the queue, n1, n2 and n3, with key values of 1, 2 and 3 and whatever the data. Currently we are only interested with the key. Now we want to insert n4 with the same key of 3. Okay, that's the scenario. So how do you check if node exists? That is, when you try to insert this n4 inside the queue, you have to take its key and check with every node inside the queue, right? So that iteration has to happen. How does that happen? So we create a temporary pointer named node star temp, and we say equal to front. So front is a pointer which is pointing to the front of the queue, right? You can see that the address of the first node n1 is stored inside the front of the queue. Now that address is now stored in the temp pointer. Why we require this? We are going to use this to iterate through the entire singly linked list. That is we are going to use this temp pointer to traverse throughout the list, right? Okay, so next step. The next step, we create a boolean variable, boolean exist equals to false. Now we have to check if there exists any node with the same key value of n4's key. N4's key is 3, and we have to check if any of the node in the queue, that is n1, n2 and n3, has the same key. So initially what we create is we create this variable bool exist equals to false. Now we use this while loop. We say while temp not equals to null, and I'll explain to you what this condition is. But inside this we will say if temp of key equal to n of key, then exist equals to true and break. And after this, in the same while loop, we say temp equals to temp of next. Okay, so what did I do just over here? So initially you can see temp is storing the same address which was there in the front. So front was pointing to n1, so n1's address is also there in the temp. So while temp not equals to null, which means that this while loop will run till the temp is not equal to null. Right now temp is not equal to null, temp is pointing to n1. So we will go inside the loop. Inside the loop we make a check if temp of key. So temp is a pointer which is pointing to n1 right now. So using this temp pointer we can access the key of n1, right? Because temp is pointing to n1 only. So we can access n1's key. Now the reason we can directly use this syntax is because temp is a pointer, and to access the data members or member functions of any object, we have to use this syntax if this temp is a pointer. If it was a normal object, we have to use dot operator, right? But since it is a pointer, we have to use hyphen and this arrow. And also the reason why we can directly access the data members is because if you observe in the node class, we have declared everything in the public section. You can see this is the public access modifier. So in general or typically in object-oriented programming, the data members are kept private and the functions or member functions or member methods are kept public. So using these member functions only you can access the data members. But to make it easy or to make things easier, I've kept everything public. So everybody can access data members of this object node, and hence we can use directly temp hyphen key. Otherwise we will simply have to use extra getter and setter methods. It's not a big hassle, but it will just save some line of code. But yeah, since temp is pointing to n1 right now, we will access the key. n1's key is 1. So is 1 equal to n of key. So what is this n of key? So remember we are passing a pointer node inside the function also. You can see node star n. So node star n means argument is also going to be a pointer of type node. So this n is this new n4 that we are trying to pass. So n4 of key is going to check with temp of key, which is n1 of key, and 1 is not equal to 3, right? Currently n, which is n4, basically has the key of 3. So is 1 equal to 3? No. So this if will not be executed. We will come outside the if and then we will say temp is equal to temp of next. So what does this line do? So remember temp is pointing to n1. What is the address inside n1's next? It is n2. right? Because n1 is pointing to n2, and the way it is doing it is by using the next pointer. So now the next pointer's address, which is n2's address, is now stored in temp. So now our temp will start pointing to n2. So you can see how we are traversing from n1 to n2 to n3. Similarly, this while loop will again be executed because temp is not null, because temp is pointing to n2. So n2's key is checked with n4's key. n2's key is 2, n4's key is 3, it is not equal, so if block is not executed, we will again say temp equals to temp of next. So temp is pointing to n2, n2's next pointer is pointing to n3. So n3's address is now stored in temp, and temp starts pointing to n3. Again, while temp not null, yes, temp is not null because temp is pointing to n3. Now we will check n3's key, which is 3. Is it equal to n's key? N is n4, n4's key is also 3. So now this if condition becomes true. We will go inside this, we will say exist equals to true, and we will say break. Once we say break, we will completely exit outside this loop, and the exist variable has become true. So lastly, we will just say return exist. So check if node exists this time will return true because exist has become true. Now imagine if n4's key was 4, we would have never gone inside the if statement because temp of key, which is pointing to n1, n2 and n3, would have never matched the key of n4 because n1, n2 and n3 have 1, 2 and 3 as the key and n4 has 4. So this matching would have never happened, and hence exist would have never become true. So initially exist was false, and that is the state that would have returned. So we would have returned false. So I hope you understand how check if node exist function would work. And this is the entire check if node exist utility function. Alright, so now let's move ahead and now take a look at enqueue function. Now in enqueue function we have 3 conditions. You can see in the pseudocode we have 3 basic blocks. The first condition is if the entire queue is empty. If the queue is empty, we can directly enqueue the node, right? Because that would be the very first node. So in that case, you can see in the pseudocode also, we directly enqueue the node and we make front and rear point to that first node. Now since the queue will have its very first node, both front and rear pointer will point to the same node. And that is what is there inside the pseudocode as well. So that is the first condition. The second condition is if the node that we want to enqueue already exists inside the queue. So this is the same condition that we just check using this function. That's why I created this first. So imagine again our same scenario where we have n1, n2 and n3 already inside the queue and we want to insert n4. n4 also has the key of 3 and n3 also has the key of 3. In that case, we do not want n4 to be enqueued. We want to show an error message saying there already exists a node inside the queue with the same key as the node that you are trying to enqueue. Correct? So that's why the second condition is to check if that node already exists. And the third is where if first and second condition are not true, then we simply add the new n4 inside the queue at the rear end. Okay? So I'll just paste the code of the entire function. We'll go line by line. Typing out is just gonna waste some time. So this is the void enqueue function. We again pass a pointer to a node object. So n is nothing but a pointer to a node object. First we check is empty. If it is empty, then this n is our very first node that we are trying to enqueue. Let's say our queue is empty and we want to enqueue the first node n1. So this n1's address is going to be stored inside the front and rear pointers of the queue class, and we will simply say node enqueued successfully. Second condition is to check if node exists. So we will take this same pointer to the node. We will pass in the check if node exists because check if node exists expects a pointer of node type, and if that node exists, then we will say node already exists with this key value, enter different key value. And if both these conditions are not true, lastly it would mean that we have some values inside the queue n1, n2 and n3, and n4 is supposed to be enqueued at the rear end, and n4 has a different key value, so you can directly enqueue it. So in that case, imagine that we have 3 nodes already. So rear is pointing to n3, front is pointing to n1. Now we want to enqueue one node n4 from the rear end, because when we enqueue data in a queue, it happens from the rear end, right? So now we will say rear of next equals to n. So rear is pointing to N3. What is the address stored in the next pointer of N3? Initially it is null. Right now it is null. But now since N4 is supposed to be added, we will make N3 point to N4. How do we do that? By using this rear pointer, because rear pointer is also pointing to N3. So we will say rear of next, which actually means N3 of next, and we will store N, which is actually N4, address of N4, because it is a pointer. Pointer always has address, right? So this address is stored in the next pointer of N3, and that's how you link N4 to N3. And now of course N4 becomes the rear end, right? Because initially N3 was the rear end, but now since you enqueued N4, the rear pointer also has to point to N4. So we again say rear equals to N. So whatever address N4 has is stored in the rear pointer, and now rear pointer starts pointing to the N4, which is actually end of the queue. And again we will say node enqueued successfully. Pretty basic. Okay, so let's move forward. So after enqueue we have another standard queue operation which is called dequeue. So when you dequeue a node from a queue, it happens from the front end. So let me just paste the code and also show you the pseudocode, and we will go step by step. Okay, so this is node dequeue. Now the return type of dequeue function is a node pointer, because when you remove a node from the queue, you want to access the values of that node, right? And you want to access them in the main function. So that's why node star dequeue, and this node star represents that this dequeue function will return a pointer which is of type node. Okay, that's the syntax. Alright, so initially we will say node star temp equals to null. Again, let's imagine we have 3 nodes N1, N2 and N3. As shown in the diagram, front is pointing to N1, rear is pointing to N3, and you want to dequeue now. So when you call dequeue, obviously we can only remove the front end. So we want to remove N1. So first we will create a temp pointer of type node. We will store null in it. Then we will check if is empty. From the current scenario, of course, our list is not empty. Our queue is not empty basically. If it would have been empty, we would have said queue is empty and not stack empty. That is the previous code. And we will return null. But since it is not empty, we will go in the else part. Now in the else part, we have 2 different scenarios. And the 2 different scenarios are for when we have only one single node inside the queue and when we have multiple nodes inside the queue. And we'll go through both of them. But let's check if front equal to rear. Now when is front and rear equal? Only when the queue is either empty or we have only one element inside the queue. When we have one inside the queue, both front and rear is pointing to the same node. But right now you can see we don't have single element or single node inside the queue. From the diagram you can see that we have 3 elements, that is 3 nodes inside the queue. So front is pointing to N1 and rear is pointing to N3. So this if will not be executed because front is not equal to rear. So now we will go inside the else part. We want to dequeue N1. So we will store the address of N1 in the temp pointer that we created at the top. This is where we created that. Then we will say front equals to front of next. So front is currently pointing to N1. N1's next, that is the next pointer inside N1 node, is having the address of N2. So that N2 address is now stored in the front pointer. So front will start pointing to N2 and we will say return temp. Temp has the address of N1. So that would be returned because we have to dequeue N1, right? So that would be returned from this dequeue operation. And this is basically the dequeue function. Now imagine if we had only one element N1, in that case, this if would have become true, right? Because front and rear would have been equal. In that case, some extra things have to be done. The temp equals to front is obviously going to be the same. So we will return temp only. But before returning temp, front and rear has to be made null. Because once we return the only single node in the queue, our queue will become empty. And remember, when the queue is empty, front and rear has to have null. So that's why we have to make front and rear null over here. That's the only extra thing. Alright, so this was the dequeue operation. I hope you're getting it. If I'm going a little faster and if you're still confused, I would highly recommend that you watch part 1 because that's where we've gone step by step with the diagrams. Over here also I'm trying to depict the digital diagrams, so that would be a little easier to understand. But anyways, moving on to the next operation. The next operation is the count operation, which, as the name suggests, gives the number of nodes inside the queue. And this is a pretty basic operation. We will say int count. Int is the return type of this count function because we want to know how many number of nodes exist. Initially we will make the count as 0. Then we will create a temporary node pointer and we will store the address of front. So I can imagine 3 nodes inside the queue, n1, n2 and n3. Front is pointing to n1, so n1's address is stored in the temp. We will use the same methodology of traversal by using the while loop, while temp not null, count plus plus and temp equals to temp of next. So in every iteration, temp will initially start point to n1, count will become 1. Then temp equals to temp of next, so temp will start pointing to n2, count will become 2. Then temp will point to n3, count will become 3. And at the last iteration, when we say temp is equal to temp of next, when temp is pointing to n3, n3's next is null. You can see n3 has a next pointer of null. So that null is stored inside this temp. So when the condition again will be checked, temp not equal to null, this condition will become false because temp is null. So this while loop was executing only till temp is not null. But when temp becomes null, this while loop will stop executing, and in that way count has become 3 and we will say return count. So this is the basic count function. So one last function left is the display function, where we display all the nodes inside the queue. So this is again a basic function which is just printing out the different nodes. Initially we check if the queue is empty. If yes, we will say queue empty. In else, we will say all values in the queue are. Then we will again use the same methodology of traversing the entire list. We will say node star temp equals to front, and we will say while temp not null and simply access the key. So in the cout, we will say temp of key, comma, temp of data, opening and closing brackets, and then this singly linked list icon, which shows that it is a singly linked list which is working like a queue. And then we will say temp of next. So pretty basic. This was the last display operation. And now that we've created all the individual queue operations, let's go in the main function again to check how every operation is called. So when the user enters 1, that is enqueue, in the switch case, the case 1 is for enqueue. So we will say enqueue function called. We will ask the user enter key and value of the node to enqueue. So the user will enter the key and data, right? So this is why in the main function at the top you can see I have created option key and data. So key and data is taken from the user. Remember we created a pointer new node, so node star pointer new node, which is pointing to an object in the heap memory of node. So we will use this pointer to access the key of that node, and we will store the key that the user enters. So node of hyphen key equals to key and node of hyphen data equals to data. Now that node inside the heap memory will be enqueued using the queue object queue. So we also created a queue object. You can see queue. We will say queue dot enqueue. Now enqueue operation takes in a pointer of type node, right? And new node is exactly that. So that's why we created a pointer methodology of creating new objects. So new node is a pointer to an object of node which is there in the heap memory. So we simply pass new node. So just scrolling up to the enqueue function, you can see it takes an argument, it takes a parameter of pointer type. By the way, this syntax and node star space n syntax is one and the same thing. Both of them are same, right? So you can say node star n or node space star n. Both of them mean the same thing. So don't get confused with that. So this is enqueue operation. I hope you understood how in the main function we are using this pointer new node, taking the values from the user, assigning it to the new node pointer object, that is pointer to that object, and then passing the address new node into the enqueue operation. Similarly, when the user enters 2, we do the dequeue operation. Now remember, dequeue returns us a pointer of type node, which means that it returns the address of the dequeued node. So if we have n1, n2 and n3 in the queue, n1 being the front of the node, n1's address will be returned from the dequeue operation. So that has to be on the RHS, and on the left hand side we have again this new node that we create, because new node is also a pointer of type node, so it can store the address of this dequeued node. And then we will say dequeued value is, using this new node we will print the key and we will print the data, right? So we also have to delete this node. As I mentioned, when you create any object in the heap memory, any object using dynamic memory allocation, you have to explicitly delete it, otherwise it remains in the memory throughout the entire program. Now if you want, you can keep it as it is, but it is always a good practice to delete that new node. So when you delete the new node, n1 will be completely and permanently erased from the memory, because you have completely dequeued it, right? Okay. Case 3 is isEmpty. We will say q.isEmpty. If q.isEmpty is true, we will print q is empty, else q is not empty. Pretty basic. Case 4 is again count. We will print count function called, and we will say number of nodes in the queue, and we will say q.count. This will return a number that will be printed over here. So number of nodes in the queue and then the number of nodes. And case 5 is display function called. We will say q.display, which simply prints out all the nodes inside the queue. Case 6, as I mentioned, is to clear the screen. And the default case, where if user enters some random number like 10, 15, 16, we will say enter proper number. Okay. Alright, so this is the entire main function. Let's save this and let's go to execute, compile and run, and let's see if this works. Okay, I think I made a little typo over here. You can see this extra symbol. It got printed and typed by mistake. Anyways, everything else seems correct. Go to execute, compile and run. Okay, our entire program is working fine, which means queue using linked list has executed successfully. But now let's see if things work. Now initially when the queue object is created, of course it is going to be empty. So let's enter option number 3. Option number 3 is for isEmpty. It should be true. When I hit enter, you can see isEmpty function called, and I'm getting the output queue is empty. Now after this, again I'm getting the entire menu driven program because I entered option number 3. When I enter option number 0, this program will stop. If I enter 0, hit enter, you can see process exited and the program stopped. Okay, let me execute it again. Now let's enter count. Count of course initially has to be 0. So there you go, number of nodes in the queue is 0. Let's enqueue one node. When I hit 1 and hit enter, the enqueue operation is called. You can see enqueue function called. Enter key and value of node to enqueue. I'll enter the key as 1 and value of 10. When I hit enter, you can see node enqueued successfully. Okay, let's see if the queue is empty now. Option number 3. See, queue is not empty. Let's see the count. Option number 4. You can see count function called. Number of nodes in the queue is 1. So this means count and isEmpty is working perfectly fine. Let me just clear the screen. Option number 6. Hit enter and the entire command prompt is cleared. Let's enqueue one more value. Let's say key as 2 and value as 20. Alright, this node is also enqueued successfully. Now let's see display function and let's see what do we have inside the queue. When I hit option 5, there you go, you can see all values in the queue are the first value of 1 and 10, then the singly linked list icon which is linked to second node 220, again singly linked list icon which has nothing over here, so that's null. But this singly linked list is working like a queue, because when we add new nodes, it will only add over here. That is, enqueue function will only enqueue one node at the end and not at anywhere in middle or at the start. But when you want to remove a element from this singly linked list, it will be only removed from the start, that is from the front. Hence this singly linked list is working like a queue. So let me just clear the screen and add one more element, 330. In fact, let me enqueue one more, 4 and 40. Let's clear the screen. So now let's see how many elements we have. I'll go to the display function. You can see all elements or values, all nodes in the queue are 1, 2, 3 and 4. Count will be also 4. There you go, number of nodes in the queue are 4. Clear the screen. Let's add one more element, but this time we will try to duplicate a key value. I'll enter the key value of 3 and the value can be anything, 50. Now we know that there exists a node n3 with the key value of 3. So we should get an error. When I hit enter, you can see node already exists with this key value. Enter different key value. So our check if node exists function is also working fine. Let's do the display one more time. We have 1, 2, 3 and 4. Let me clear the screen. Display function again, and now let's do the dequeue. So remember, dequeue always happens from the front. Over here the front is 1 and 10. So this element has to be removed, right? So when I hit 2, which is option 2 for dequeue, and hit enter, you can see dequeue function called. Dequeue value is 1 and 10. So 1 and 10 is now removed from the queue. So if it is truly removed or not, we will find out by using the display function. When I hit 5, you can see now display function called all values in the queue are 2, 3 and 4, which means that the first node with the key value of 1 is completely removed, and our program, our queue using singly linked list is working perfectly fine. Okay, so this is the entire implementation, the entire practical code of queue using singly linked list, the implementation side. I hope you understood the entire program, and if you did, please give this video a like. Let me know in the comments how this video was. Do share it with your friends, this is important. You can visit our official website for this code and some extra explanation, and also all the other resources that we are going through in this entire DSA course. Definitely subscribe if you are new on this channel. We have a lot of programming tutorials and many more are coming soon. And I'm going to conclude my video over here. Thanks for watching. See you in the next one. Peace.